close your eyes for a moment and imagine this. There are more stars in the universe than grains of sand on every beach on Earth. Around those stars orbit countless planets, many of them possibly harboring the conditions for life. With such staggering numbers, the universe should be teeming with civilizations far older and more advanced than our own. And yet, when we look out into the cosmos, when we listen with our most sensitive instruments, we hear nothing but silence. Not a single confirmed signal. Not one visitor. Whisper. This is the Fermi Paradox, and for the next hour, you and I are going to sit with this beautiful, unsettling mystery together. It was a summer day in 1950 when physicist Enrico Fermi posed a question so simple that it changed how we think about our place in the universe. He was having lunch with colleagues at Los Alamos National Laboratory, and the conversation had drifted to recent reports of UFO sightings. Fermi listened quietly, his brilliant mind calculating probabilities and timescales. Then, almost casually, he asked the question that would become his legacy. Where is everybody? 3 words that contained within them an entire universe of implications. If intelligent life is common, if the cosmos has been around for billions of years, then where are all the alien civilizations? Why haven't they visited us? Why can't we see any evidence of their existence? You see, Fermi understood something that still troubles scientists today. The universe is unimaginably old. Our sun and Earth are only about 4.5 billion years old, but the universe itself has been around for over 13 billion years. That means there were stars and planets forming billions of years before our world even existed. If intelligent life developed on even a handful of those ancient worlds, they would have had an enormous head start on us. Millions or even billions of years to develop technologies we can barely imagine. Where are their massive structures? Where are their signals? Where are their spacecraft? The silence is deafening. The paradox is not just about whether aliens exist. It is about the stark contradiction between what the mathematics predicts and what we actually observe. On paper, the universe should be crawling with life. Probability suggests that even if intelligent life is rare, the sheer number of planets should guarantee that we have cosmic neighbors. And yet, when we turn our telescopes to the stars, when we aim our radio dishes at distant systems, we find only emptiness. Only silence. Only silence. This gap between expectation and reality is the heart of the Fermi Paradox, and it is one of the most profound mysteries we face. Take a moment and let this settle in. You are living in a universe that by all logical reasoning should be teeming with intelligence, and yet you have never seen a single piece of definitive evidence that we are not alone. No alien transmission has ever interrupted our broadcasts. No extraterrestrial probe has ever been found in our solar system. No mysterious monuments on distant moons betray the presence of visitors from long ago. We appear to be the only voices in a cosmic auditorium designed to hold billions. How does that make you feel? Does it make you feel special, or does it make you feel profoundly lonely? Some people find comfort in the idea that we might be alone. It makes humanity special, unique, the universe's only conscious observers. But others find it unsettling, even terrifying. The implications are vast and often dark. If we are alone, it might mean that the emergence of intelligent life is so improbable that we are a cosmic fluke. Or worse, it might mean that something awaits all civilizations that reach a certain level of development. Something that prevents them from spreading across the galaxy. Something that filters them out. We will explore these possibilities together, but for now, let the question simply exist in your mind. Where is everybody? Throughout history, humans have grappled with our place in the universe. Ancient cultures placed Earth at the center of creation, with the heavens revolving around us. Then Copernicus showed us that we orbit the sun, not the other way around. We learned that our sun is just one of hundreds of billions of stars in our galaxy, and that our galaxy is just one of trillions in the observable universe. Each discovery made us smaller, less central, less special. And yet, when we search for others like us, we find none. Are we witnessing the final, most ironic twist in the Copernican story? That, in a universe so vast, we are somehow still alone? The question Fermi asked that summer day has only grown more urgent with time. We now know that planets are not rare. In fact, they are abundant beyond our wildest expectations. Nearly every star you can see in the night sky likely hosts at least one planet. Many of those planets exist in what we call the habitable zone, where liquid water can exist on the surface. The ingredients for life as we know it are scattered throughout the cosmos. The recipe seems to be everywhere. So, why have we not tasted the results? Why does the cosmic kitchen appear so empty? This is what we will explore together. Not with anxiety, but with calm curiosity. Let us journey into the silence. Before we go further, I want you to do something for me. Take a slow, deep breath. Feel your chest rise and fall. You are here now, alive and conscious in a universe that is asking you to witness its mysteries. The Fermi Paradox is not a problem to be solved in haste. It is a meditation, a reflection on existence itself. For the next hour, allow yourself to float through these ideas without grasping for definitive answers. Let the questions wash over you like waves. Some mysteries are meant to be experienced, not explained. And in the silence of the cosmos, perhaps we will find something profound about ourselves. To truly understand the Fermi Paradox, we first need to grasp the scale of the universe. And I mean truly grasp it, not just intellectually acknowledge it. The numbers involved are so large that they become abstract, meaningless. So let us bring them down to human scale for a moment. Imagine you are holding a grain of sand between your fingers. That grain represents our sun and its planetary system. Now imagine all the beaches on Earth, every shoreline, every grain of sand. That still does not come close to the number of star systems in just our galaxy alone. We are talking about hundreds of billions of stars, each potentially hosting worlds of their own. Our Milky Way galaxy is a vast spiral of stars, gas, and dust stretching about 100,000 light years from edge to edge. A light year is the distance light travels in a year, moving at 300,000 kilometers every single second. Light could circle the Earth more than 7 times in 1 second. And yet it takes light 100,000 years to cross our galaxy. Let that sink in for a moment. Even traveling at the ultimate speed limit of the universe, it would take you 100 millennia just to cross our cosmic neighborhood. And this is just one galaxy among trillions. Now here is where it gets even more humbling. Our Milky Way is part of a local group of galaxies. Beyond that, there are clusters and superclusters of galaxies, creating a cosmic web that stretches across the observable universe. Current estimates suggest there are at least 2 trillion galaxies in the universe, possibly more. 2 trillion galaxies, each containing hundreds of billions of stars. The total number of stars in the observable universe is thought to be around 1 septillion. That is a 1 followed by 24 zeros. Can you even imagine such a number? It is larger than all the thoughts you will ever think, all the breaths you will ever take. With such unfathomable numbers, you might think that intelligent life should be common, perhaps even inevitable. If even a tiny fraction of those septillion stars host planets with conditions suitable for life, And if even a minuscule percentage of those develop intelligence, we should be surrounded by countless civilizations. The mathematics seems irrefutable. The universe should be noisy with signals, busy with traffic, filled with evidence of others. But it is not. We have sent our messages into the void. We have listened with ever more sensitive instruments, and we have heard nothing in return. Only the natural radio emissions of celestial objects. Only the blind, unconscious physics of stars and galaxies. Let us think about time as well as space. The universe has been around for about 13.8 billion years. Earth formed about 4.5 billion years ago. For the first billion years or so, our planet was hellish, constantly bombarded by asteroids, its surface molten. But life emerged relatively quickly after that, within the first billion years of Earth's existence. Simple, single-celled life, yes, but life nonetheless. This tells us something important. The jump from non-living chemistry to living biology might not be as difficult as we once thought. The building blocks are there, scattered throughout the cosmos. Amino acids have been found in meteorites. Organic molecules drift in interstellar clouds. But here is the catch. While simple life appeared quickly on Earth, complex life took much, much longer. For billions of years, Earth was inhabited only by single-celled organisms. It took extraordinary circumstances and unlikely events for life to become multicellular, for plants to colonize land, for animals to develop complex nervous systems. Intelligence, as we understand it, is a very recent innovation. Our species, Homo sapiens, has only been around for about 300,000 years, and we have only had radio technology for about a century. In cosmic terms, we have been capable of sending and receiving signals for the blink of an eye. Perhaps other civilizations experience similar delays. Perhaps intelligence is the rare part, not life itself. There is another layer to consider. The universe was not always suitable for life as we know it. In the early universe, there were no heavy elements. Stars must live and die, forging carbon, oxygen, nitrogen, iron, and all the other elements necessary for complex chemistry in their nuclear furnaces, then scattering those elements through space when they explode. The first generations of stars contained only hydrogen and helium. It took billions of years for the universe to be enriched with the building blocks of planets and life. We might be part of the first wave of intelligence to emerge after the cosmos became habitable. If that is true, we should not expect to find ancient, galaxy-spanning civilizations. They simply have not had time to exist yet. So we find ourselves in a universe that is almost incomprehensibly vast, unimaginably old, and filled with the ingredients for life. Its age is set. The actors should be numerous. And yet, we appear to be performing a monologue in an empty theater. Does the silence mean we are truly alone? Or does it mean that space and time are so vast that civilizations simply never cross paths? Could it be that intelligence is shouting across the cosmos, but the distances are so great and the signals so faint that we pass each other like ships in an infinite night? These are the questions that will guide us deeper into the paradox. For now, simply feel the weight of these scales. The universe is big, almost too big to bear. In 1961, a young astronomer named Frank Drake organized the first conference dedicated to the search for extraterrestrial intelligence. Before the meeting, he wanted to structure the discussion, to create a framework for thinking about the likelihood of finding alien civilizations. So he devised an equation. Not a precise calculation, but rather a way of breaking down the big question into smaller, more manageable questions. This equation, now known as the Drake equation, attempts to estimate the number of active, communicative civilizations in our galaxy. It is elegant in its simplicity, and yet each term in the equation contains volumes of uncertainty. Let us walk through it together, calmly, and see what it tells us. The equation begins with the rate at which stars form in our galaxy. This number is relatively well understood. Our Milky Way gives birth to a few new stars each year, cooking up fresh stellar furnaces from collapsing clouds of gas and dust. So we start with that number, and then we multiply by the fraction of those stars that have planets. Thanks to missions like Kepler and TES, we now know this number is quite high. Planets are not rare. Most stars have them. In fact, it is looking like planetary systems are the rule, not the exception. So far, the numbers are looking good for finding others out there. The universe is full of real estate. Next, we ask how many of those planets are in the habitable zone. This is the sweet spot around a star where temperatures allow liquid water to exist on a planet's surface. Too close, and the water boils away. Too far, and it freezes solid. Liquid water is essential for life as we know it because it is an excellent solvent, allowing complex chemistry to occur. We have found many planets in these habitable zones, thousands in fact. Some orbit stars very similar to our Sun. Others circle smaller, cooler red dwarf stars, which are the most common type in the galaxy. The more we look, the more habitable zone planets we find. The potential homes for life keep adding up. Now we reach the first, truly uncertain term. Those habitable planets. On how many does life actually emerge? We only have one data point for this. Earth. Life arose here relatively quickly, which might suggest that given the right conditions, life is likely to emerge. Or it might mean we just got lucky. We simply do not know yet. This term in the Drake equation could be close to 1, meaning life is almost inevitable, or it could be vanishingly small, meaning Earth's biosphere is a cosmic fluke. Until we find evidence of life elsewhere, even just microbial life on Mars or the moons of Jupiter and Saturn, we cannot narrow this down. We are calculating in the dark. The next term is even more speculative. Of the planets where life does emerge, on how many does that life evolve into intelligence? On Earth, it took billions of years. Intelligence is not an inevitable outcome of evolution. For most of Earth's history, life was perfectly content being single-celled. Even after multicellular life arose, intelligence as we know it remained rare. Many complex organisms thrive without anything we would call intelligence. Trees, coral, jellyfish, they are all successful without self-awareness or technology. Intelligence might be a quirk, an evolutionary oddity that happens rarely. Or perhaps it is more common than we think, arising through different pathways on different worlds. We simply do not have the data to say. Then we ask an interesting question. Of those intelligent species, how many develop technology capable of communicating across interstellar distances? Humans have had radio for just over a century. For millions of years before that, our ancestors were intelligent but incapable of sending signals into space. We used fire, we made tools, we created art, but we could not reach out to the stars. Perhaps other intelligent species never develop radio technology. Perhaps they take different technological paths. Or perhaps they develop it, but choose not to use it. Maybe advanced civilizations move beyond radio to communication methods we have not yet imagined. This term adds another layer of uncertainty to our equation. The final term in the Drake equation is perhaps the most sobering. Now, how long does a technological civilization last? This is the lifespan of a communicative species. Humans have had radio for about 100 years. Will we still be broadcasting in another 100? Another 1,000? Yeah, 1,000,000? Or will we destroy ourselves, fall silent, collapse back into a pre-technological state? This term determines whether civilizations overlap in time. Even if intelligent life is common, if civilizations only survive for short periods before going extinct, the galaxy might be filled with ruins and echoes, with only brief windows where two civilizations exist simultaneously. The universe might be less empty than we think, just very lonely in its timing. When Drake first wrote his equation, with optimistic estimates for each term, he calculated that there could be thousands of communicative civilizations in our galaxy at any given time. More conservative estimates drop that number to just a handful, or even to one, which would be us. The equation does not give us a definite answer. Instead, it shows us the boundaries of our ignorance. It maps the territory of what we do not know. And in doing so, it makes the Fermi Paradox even more poignant. If the Drake equation suggests we should have neighbors, why does the universe feel so empty? What are we missing? Let us take a breath here and prepare to explore the proposed solutions to this magnificent mystery. For over 6 decades, we have been listening. In 1960, Frank Drake pointed a radio telescope at two nearby stars, Tau Ceti and Epsilon Eridani, hoping to detect signals from an alien civilization. This was Project Ozma, named after the Queen in the Oz books, a ruler of a distant and unreachable land. For about 4 months, Drake and his team listened. They heard nothing but the natural static of the cosmos. This was the beginning of SCT, the search for extraterrestrial intelligence. Since then, countless hours have been spent scanning the skies, listening across different frequencies, hoping for just one unambiguous signal. A pattern in the noise. A message in the static. But the cosmos remains silent. SETI researchers have developed sophisticated methods to sift through the cosmic noise. They look for narrowband signals, the kind of sharp, focused transmissions that are unlikely to occur naturally. Stars and galaxies emit radio waves, but they do so across a broad spectrum. A civilization trying to communicate might use a very specific frequency, creating a signal that stands out from the background. SETI listens for patterns, for mathematical sequences, for anything that suggests intelligence rather than randomness. Projects like SETI at Home even enlisted millions of personal computers to help process the data. Billions of radio frequencies have been examined, and still we find nothing definitive. The universe whispers, but it does not speak. There was one moment when it seemed like we might have found something. On August the 15th, 1977, at the Big Ear Radio Telescope in Ohio, a strong narrowband signal was detected coming from the constellation Sagittarius. It lasted for 72 seconds and was so striking that the astronomer on duty, Jerry Eman, circled it on the computer printout and wrote the word "wow" next to it. The "wow" signal, as it came to be known, matched all the criteria for an artificial signal. It has never been detected again, despite repeated attempts to find it. Was it aliens? Was it a natural but rare phenomenon? Was it interference from a passing satellite? We may never know. But for 72 seconds, humanity held its breath. Of course, listening is just one approach. We have also sent messages into space, though far fewer than we have received. In 1974, the Arecibo Radio Telescope transmitted a message toward the globular star cluster M13. The message contained information about humanity, our DNA, our solar system, encoded in binary. It will take about 25,000 years to reach M13, and if anyone there responds, their reply will take another 25,000 years to return. This is the challenge of interstellar communication. Even if civilizations want to talk, the distances are so vast that conversations become intergenerational projects. A question asked by one generation of humans might be answered long after our entire civilization has transformed beyond recognition. We have also sent physical artifacts. The Pioneer plaques and the Voyager. Golden records carry information about Earth and humanity into interstellar space. The Voyager spacecraft, launched in 1977, are now beyond the heliosphere in interstellar space. They carry greetings in multiple languages, music from various cultures, and images of Earth and its life. They are messages in bottles cast into a cosmic ocean. The chances of them being found are vanishingly small. Space is vast, and the spacecraft are tiny, but they represent something profound. Our desire to reach out, our hope that someone, somewhere might find them and know that we existed. That we cared, that we tried to make contact, but perhaps we are listening in the wrong way. Radio waves might not be the preferred method of communication for advanced civilizations. They could be using lasers, tightly focused beams of light that we would only detect if they were pointed directly at us. Some SETI programs have begun searching for these optical signals. Or maybe advanced civilizations communicate in ways we have not even conceived of yet. Quantum entanglement, neutrino beams, gravitational waves. We are searching with the tools we have, but we might be like someone trying to hear a radio broadcast without a radio, completely unaware that transmissions are flooding the air around us. The silence might not mean no one is talking. It might mean we do not know how to listen yet. There is another possibility that some find troubling. The Berserker hypothesis suggests that perhaps the galaxy is silent because any civilization that reveals its presence is destroyed by aggressive, self-replicating machines left behind by a long-extinct species. These hypothetical berserkers seek out and eliminate emerging intelligence. It is a dark scenario, like a cosmic horror story, but it would explain the silence. If this were true, then broadcasting our presence might be dangerous. METI, messaging. Extraterrestrial intelligence is controversial for this reason. Some scientists argue we should listen but not send. Shouting in a dark forest, they say, might not be wise when you do not know what is out there. Others argue that hiding is futile and counterproductive. The debate continues. For now, the great silence persists. Decades of careful listening have yielded no confirmed signals. The universe, as far as we can tell, is a quiet place. And yet, the absence of evidence is not evidence of absence. Just because we have not heard anything does not mean nothing is there. We have only searched a tiny fraction of the sky at a limited range of frequencies for a cosmically brief period of time. Imagine scooping a cup of water from the ocean and finding no fish in it, concluding that the ocean is empty. That is roughly where we are in our search. The silence is real, but what it means remains open to interpretation. Let us explore some of those interpretations together. One possible solution to the Fermi Paradox is both humbling and extraordinary. Perhaps we are not in the middle of the story. Perhaps we are near the beginning. The universe is old, yes, but it was not always conducive to life. The early universe was hot, dense, and expanding rapidly. It took time for stars to form, live, die, and enrich the cosmos with heavy elements. It took time for stable planetary systems to emerge around later generation stars. It is possible that the universe has only recently, in cosmic terms, become truly habitable. If that is true, then we might be among the first intelligent civilizations to arise. We are not finding elder species because they do not exist yet. We are the elders, the firstborn, the dawn of intelligence in the cosmos. If we are the first, it changes everything. It means the responsibility for the future of intelligence in the universe rests with us. Our choices, our survival, our expansion into space, these things matter on a cosmic scale. If we destroy ourselves, there may be no one to pick up the torch for millions or billions of years. But if we survive, if we venture out to the stars, we become the ancients that future civilizations will wonder about. We become the first chapter in a story that could last trillions of years. The silence of the universe is not a rejection. It is an invitation, an empty stage waiting for the first act to begin. and we are the actors stepping into the light. There is some scientific support for this idea. Studies of stellar metallicity, which is the abundance of elements heavier than hydrogen and helium in stars, show that older stars tend to have lower metallicity. They formed before the universe had time to build up heavy elements. Planets around these stars would lack the necessary ingredients for complex chemistry and life. Our Sun, by contrast, has relatively high metallicity. It is what we call a population I star, enriched by the deaths of previous stellar generations. This enrichment was necessary for Earth to form with its iron core, rocky mantle, and all the trace elements that make life possible. The universe needed time to prepare the ingredients. Additionally, the early universe was a more violent place. Supernova explosions were more frequent. Gamma-ray bursts capable of sterilizing entire planetary systems occurred more often. The conditions were hostile to the long-term stability needed for complex life to evolve. Even if planets formed early, they might have been repeatedly scoured clean by cosmic catastrophes. Only now, in what some call the stelliferous era, has the universe settled into a more stable state. Galaxies are more spread out. The rate of catastrophic events has decreased. The cosmic background radiation has cooled. The stage has been set. The curtain has risen. And we are stepping out to deliver the first lines, but being first comes with its own existential weight. If no one is watching, if no one is judging, if no elder civilizations exist to guide us or warn us, then we must figure everything out on our own. Every mistake we make for the first time. Every crisis we face without precedent or advice from those who have survived it before. There is no cosmic instruction manual, no one to call when things go wrong. We are writing the manual as we go, and every page matters. Future civilizations, if they arise, might look back at us and wonder how we navigated our early centuries. What will we leave for them to find? Or relics? A cautionary tale or an inspiration? Some find comfort in the idea of being first. It removes certain fears. There are no hostile alien empires to conquer us. No advanced civilizations looking down on us with pity or contempt. We are not inferior or late to the party. We are pioneers. The galaxy is ours to explore and settle if we can survive long enough to do so. Every star system could be a new home. Every world could bear our mark. In millions of years, our descendants might fill the galaxy, diverse and wondrous, looking back at Earth as the sacred origin point of it all. The silence is not loneliness. It is possibility, an empty canvas awaiting the first stroke of paint. Critics of this solution point out that it requires us to be remarkably lucky. Out of all the stars that could have hosted intelligence, why us? Why now? The universe will continue for trillions of years. Stars will keep forming. Planets will keep evolving life. For us to be the first seems statistically unlikely, a kind of cosmic narcissism. But statistics can be deceiving. Someone has to be first. If intelligence is rare, if the conditions have only recently aligned, then whoever emerges first will feel like they won an impossible lottery. And yet, someone must win. Perhaps the more interesting question is not whether we are first, but what we will do with that possibility. If there is even a chance that we are the firstborn, how should that shape our choices? Whether or not we are truly first, this explanation offers something valuable. It gives us agency. It suggests that the future is open, unwritten, waiting for us to shape it. The silence is not a prison sentence, but a blank page. We can choose to fill it with beauty, with compassion, with curiosity. We can be the civilization we wish had been there to greet us. We can be the elders future species look to with admiration. Or we can squander the opportunity, fade into the cosmic background another might have been. The choice, for now, is ours. and that is both terrifying and thrilling. So let us sit with this possibility for a moment. Feel what it means to perhaps be first in a universe so vast. Now we come to a darker possibility. Perhaps intelligent life is common. Perhaps civilizations arise frequently throughout the cosmos. But perhaps something stops them. Something prevents them from expanding, from lasting, from becoming visible to others. This is the concept of the Great Filter, and it is one of the most unsettling solutions to the Fermi Paradox. The idea is that there is a barrier, a bottleneck in the development of life or civilization that is so difficult to pass through that most species never make it. The universe might be littered with the remains of civilizations that failed to navigate this filter. The silence is not because no one is there. It is because no one survives. The Great Filter could be behind us. It might be the jump from non-living chemistry to living cells, an event so improbable that Earth is a rare exception. Or it could be the transition from single-celled to multicellular life, which took billions of years here. Or the development of intelligence itself, which seems to be vanishingly rare even among complex organisms. If the filter is behind us, then we have already beaten the odds. The hard part is over. We are the lucky ones, and the galaxy stretches before us ready for exploration and colonization. This is the optimistic interpretation. It means we are safe, that our future is bright, that the universe is ours for the taking. But what if the Great Filter is ahead of us? What if the truly difficult, nearly impossible step comes next? This is the terrifying possibility. It would mean that countless civilizations have reached our level of development, or slightly beyond, and then something stops them. Nuclear war, environmental collapse, a technological disaster we have not yet imagined, resource depletion, an AI that turns against its creators, a pandemic we cannot contain, a physics experiment gone catastrophically wrong. If the filter is ahead, then the silence is a warning. It is the universe saying that almost no one makes it past this point, and we are approaching it right now. With every passing year, consider our current trajectory. We have developed weapons capable of destroying our civilization many times over. We are altering our planet's climate in ways that could make it inhospitable. We are creating artificial intelligences that might one day surpass us in capability. We are depleting resources, causing mass extinctions, and testing the limits of our planet's carrying capacity. Any one of these challenges could be the filter, and if we fail to navigate them wisely, we join the silence. We become another civilization that rose, shone briefly, and then faded into darkness. The ruins of Mars, if they exist, might be our mirror. An earlier attempt that did not quite make it. Robin Hanson, an economist, popularized the Great Filter idea and pointed out its grim implications. If we discover simple life on Mars, that is good news. It means the filter is likely behind us. But if we discover the ruins of a complex, intelligent civilization on Mars, that is very bad news. It means the filter is not in the emergence of intelligence, but in its survival. It means reaching our level is easy. Surviving long-term is the hard part. Every discovery we make about life beyond Earth gives us information about where the filter might be. And so far, the emptiness of Mars, the silence of the cosmos, gives us no clear answer. We are navigating blindfolded. Some theorists propose that the filter might not be a single event, but a series of hurdles, each difficult to clear. Life emerges, but rarely. Intelligence evolves, but infrequently. Technology develops, but civilizations often destroy themselves shortly after. Expansion into space occurs, but is halted by unforeseen challenges. The galaxy might be full of species stuck at various levels, unable to progress further. We see no. Type 3 Kardashev civilizations consuming the energy of entire galaxies because getting to that level is functionally impossible. The universe is not empty. It is full of civilizations trapped at lower rungs, unable to climb higher. And we might be about to join them. The Great Filter concept is not just an intellectual exercise. It has practical implications for how we should behave right now. If the filter is ahead, then our survival as a species depends on recognizing the dangers and navigating them carefully. It means taking existential risks seriously. Climate change, nuclear weapons, artificial intelligence, biotechnology, these are not just policy issues. They are tests. The universe is testing us the way it has tested countless others, and the stakes could not be higher. Failure does not mean political loss or economic hardship. Failure means silence. Failure means joining the empty cosmos as another might have been. Another species that almost made it. But let us not end this segment in despair. Awareness is the first step to survival. If the Great Filter exists and lies ahead, knowing about it gives us a chance to prepare, to think carefully, to make wise choices. Humanity has faced existential threats before and survived. We have pulled back from the brink of nuclear war. We have rallied to address global crises. We are capable of cooperation, ingenuity, and long-term thinking when we need to be. The silence of the universe is not a foregone conclusion of our doom. It is a challenge. Can we be the ones who make it through? Can we be the civilization that proves the filter can be passed? Time will tell. Oh, now breathe and let us continue exploring the possibilities. Imagine for a moment that you are walking through a dark forest at night. You cannot see more than a few meters ahead. You hear rustling in the bushes, the snapping of twigs, but you do not know who or what is out there. Are they friendly? Hostile? Indifferent? The safest strategy is to stay quiet, to avoid drawing attention to yourself, to remain hidden. This is the dark forest theory, a chilling solution to the Fermi Paradox proposed by science fiction author Liu Cixin. It suggests that the universe is not empty. It is full of civilizations, but they are all hiding from each other because the cosmos is a dangerous place and revealing your presence might be the last mistake you ever make. The logic of the dark forest is ruthless but sound, at least from a certain perspective. In a universe where resources are finite and the intentions of others are unknowable, the safest assumption is that any other civilization is a potential threat. If you detect another intelligence, you have two choices. Attempt contact, revealing your position and capabilities, which is risky. Or eliminate the threat before it can eliminate you, which is brutal but effective. Since you cannot know their intentions, and since the cost of being wrong is extinction, the rational choice is to strike first. Or better yet, never reveal yourself at all. Silence becomes survival. The cosmos is a vast game of hide and seek, where being found means death. If the dark forest theory is correct, then the silence we observe is not emptiness. It is caution. Every advanced civilization has concluded that broadcasting their presence is suicidal. They have learned, perhaps through bitter experience or through witnessing the fate of less careful species, that the universe punishes the loud. So they watch. They listen, but they do not speak. They have cloaked their activities, hidden their energy signatures, and gone dark. The galaxy is teeming with intelligence, but it is a cold, paranoid intelligence. A civilization of watchers, each afraid to make the first move. And we, broadcasting our position with radio waves for a century, might have just painted a target on ourselves. This theory raises an uncomfortable question. Should we stop broadcasting? Should we pull back our radio signals, power down our transmitters, and join the silence? Some scientists argue yes. Meaty, actively messaging extraterrestrial intelligence might be phenomenally dangerous. We are children shouting into a dark alley, not knowing what might answer. Others argue that it is too late. We have already been broadcasting for decades. If anyone nearby is listening, they know we are here. And besides, hiding might not save us. If the logic of the dark forest is universal, and if a civilization detects us even passively, they might decide to eliminate us preemptively, whether we are shouting or whispering. Silence might not be safety. Critics of the dark forest theory point out that it assumes a fundamentally hostile universe, which might not be the case. Cooperation and altruism exist on Earth. Species form symbiotic relationships. Empires trade and negotiate. Why would the cosmos be any different? Perhaps advanced civilizations overcome their paranoia. Perhaps they develop ethics and norms that discourage preemptive strikes. Perhaps they recognize that a universe full of hiding, frightened species is a poorer, sadder place than one full of cooperation and exchange. The dark forest might be a phase, a young civilization's nightmare that mature species grow out of. We can hope, but hope is not a strategy when survival is at stake. There is another layer to the dark forest. Perhaps the universe is silent because any civilization that announces itself is not just attacked but utterly annihilated, leaving no trace. The cosmos might have cosmic immune systems, automated defense networks left by ancient species to prevent the rise of competitors. Like antibodies attacking an infection, these systems might detect emerging intelligence and eradicate it before it spreads. If this is the case, then the galaxy has been sanitized repeatedly over billions of years. We see no one because no one is allowed to survive long enough to be seen. And our radio signals, our Voyager probes, our optimistic messages might have already triggered a response that is speeding toward us at a fraction of the speed of light. The dark forest theory forces us to confront an uncomfortable truth. We do not know what is out there. We do not know the rules. We do not know if the universe is friendly, hostile, or indifferent. We are making decisions about our cosmic presence in a state of profound ignorance. Every signal we send, every light we shine into the darkness is a gamble. Maybe we are inviting friendship. Maybe we are inviting annihilation. The fact that we have survived this long without consequence might mean we are safe. Or it might mean we are simply lucky and our luck is about to run out. The silence might be a blessing. Or it might be a warning we are too naive to understand. Let us sit with the discomfort of the dark forest. It is a cold, paranoid vision of the universe. But it is not necessarily wrong. It reminds us that the cosmos does not owe us anything. Safety, companionship, understanding, these are not guaranteed. The universe is vast, ancient, and operates by rules we are only beginning to grasp. If other civilizations have learned to fear the darkness, perhaps we should too. Or perhaps, just perhaps, we can be different. We can be the civilization that takes the risk, that extends the hand of friendship despite the danger, that refuses to live in fear. It is a choice. And like all choices, it comes with consequences. For now, the forest is silent, and we are left to wonder what moves in the shadows. Perhaps we are looking for the wrong things. We imagine alien civilizations as we imagine ourselves, building cities, sending out radio signals, constructing megastructures around stars. But what if intelligence can take forms so different from ours that we do not recognize it when we see it? What if they are here, all around us, and we simply lack the framework to perceive them? This is a more exotic solution to the Fermi Paradox, But it is worth considering. Maybe the universe is not silent. Maybe we are deaf. Maybe we are looking at a message written in a language so alien that it appears to us as noise or nature or nothing at all. Consider this. Human civilization has existed for about 10,000 years. Technological civilization for a few hundred. Our entire species has been around for 300,000 years, which is a blink in cosmic time. If an alien civilization is millions or billions of years more advanced than us, their form and behavior might be as incomprehensible to us as our technology would be to an ant. They might not live on planets. They might not have bodies. They might exist as patterns of information in quantum fields or as distributed intelligences across entire star systems. They might have transcended physical form entirely. How would we recognize such beings? What would their activities look like to us? Some theorists propose that advanced civilizations might retreat inward rather than expand outward. Instead of conquering galaxies, they might build virtual realities, creating universes within their computers that are far more interesting than the physical cosmos. Why travel to distant stars when you can create infinite worlds in simulation? Why bother with the limitations of physical space when you can explore limitless digital space? If this is the path most civilizations take, then the silence makes sense. They are not out here with us. They are inside, exploring realities we cannot see or touch. The universe is quiet because no one is interested in the universe anymore. They have moved on to better things. Then there is the zoo hypothesis. Maybe they know we are here. Maybe they have been watching us for a long time, but they choose not to interfere. Think of it as a cosmic non-interference policy, like a wildlife preserve where animals are observed but not contacted. Perhaps Earth is a nature reserve, a protected site where a young civilization is allowed to develop naturally without the corrupting influence of advanced aliens. They might have rules, time directives, ethical guidelines that prevent them from revealing themselves until we reach a certain level of maturity. We might be living in a zoo, and the zookeepers are just outside the fence watching us with interest but unwilling to step inside. Another possibility is that they communicate in ways we have not yet discovered. Maybe they use gravitational waves to send messages. Maybe they encode information in the cosmic microwave background radiation. Maybe they manipulate dark matter or dark energy, the invisible substances that make up most of the universe. We have only recently detected gravitational waves at all. Imagine trying to listen to radio before radios were invented. You would hear nothing, but the signals would be there, passing through you constantly. Perhaps the cosmos is buzzing with transmissions we cannot detect because we do not yet have the right instruments. The silence is not real. It is our limitation, or perhaps they have been here and left long ago. Ancient astronaut theories aside, it is possible that Earth was visited millions or billions of years ago, and any evidence has been erased by geological processes. 1,000,000 years is a long time. Continents shift, oceans rise and fall, ice ages come and go. If aliens visited during the Jurassic period or during the time of the first multicellular life, there would be no traces left for us to find. The planet has been wiped clean over and over. They might have looked at Earth, seen it was not yet interesting, and moved on. Maybe they will come back when we become worth talking to. Or maybe they already decided we are not worth the trouble. There is also the possibility that consciousness itself is the final frontier, not space. Advanced civilizations might explore inner space rather than outer space. They might focus on expanding the mind, enhancing cognition, exploring the nature of awareness and subjective experience. Meditation, philosophy, transcendental technologies that we cannot even imagine. If the ultimate mysteries lie within rather than without, then star travel becomes a curiosity, a hobby, not the main event. The universe is quiet because the wise have learned that the real journey is not across light years, but across layers of consciousness. They are not ignoring us. They have simply found something more profound to attend to. These solutions all share a common theme. They suggest that our expectations are wrong, that we are looking for the wrong signals, in the wrong places, in the wrong ways. Maybe the Fermi Paradox is not about the absence of aliens, but about our inability to recognize them. It is a humbling thought. We like to think of ourselves as intelligent, perceptive, capable. But what if we are like ants trying to understand the internet? We see the cables, we experience the effects, but we have no framework for grasping what it actually is. The silence might not be silence at all. It might be a symphony we cannot hear. And the challenge is not to find them, but to evolve ourselves until we can. Let that thought settle. Feel the possibility. Sometimes the simplest explanations are the most profound. Perhaps the Fermi Paradox has no exotic solution. Perhaps the universe is not empty, but space is just unimaginably vast, and time is almost unbearably long. Civilizations might exist, scattered across the cosmos, but they are so far apart in space and time that they never meet. Two ships passing in an endless night, each unaware of the other. This is less dramatic than filters or dark forests, but it might be the truth. The universe is big, bigger than we can fully grasp. And in such immensity, even billions of civilizations could be hopelessly isolated from one another, each calling into the void, each hearing only echoes of their own voice. Let us consider the speed of light. It is the ultimate speed limit of the universe, as far as we know. Light travels at about 300,000 kilometers per second, which sounds fast. But space is so vast that even light takes years, centuries, millennia to cross it. The nearest star to us, Proxima Centauri, is about 4 light years away. A message sent there today would not arrive until 2029. A reply would not reach us until 2033. That is a 9-year conversation. The center of our galaxy is about 26,000 light years away. A signal sent there today would arrive in the year 28,025. Any response would reach Earth in the year 50-50-50. Conversations at this scale are not conversations. They are messages in bottles sent across oceans of time, and space travel is even slower. Our fastest spacecraft, the Parker Solar Probe, travels at about 400,000 kilometers per hour relative to the Sun at its peak speed. That sounds fast, but it would still take about 6,500 years to reach Proxima Centauri. A human lifetime is, generously, 100 years. Interstellar journeys would be multi-generational endeavors. The people who arrive would be the distant descendants of those who left. If other civilizations face the same limitations, then physical visits are extraordinarily difficult. Even if they know we are here, even if they wanted to visit, the journey might be impractical or impossible. The universe does not facilitate meetings. It enforces solitude. Now add time to the equation. The universe has been around for over 13 billion years. Earth has been habitable for a few billion. Humans have had technology for a few hundred. In that vast span, civilizations might rise and fall, separated by millions of years. Imagine 2 civilizations in the same galaxy, each lasting 1,000,000 years, which would be impressive. But if one existed 5 million years ago and the other exists now, they would never overlap. they would never communicate. Each would look out and see an empty universe, concluding they are alone. The cosmic neighborhood might be bustling over deep time, but at any given moment, most houses are empty. The party happens, but the guests arrive at different times, never meeting. Consider also the fragility of signals. Radio waves spread out as they travel, becoming weaker with distance. By the time a signal from Earth reaches another star system, it is almost indistinguishable from background noise. Detecting it would require enormous antennas and perfect timing. And our signals have only been traveling for about a century. They have reached only a tiny bubble of space, a few hundred stars out of hundreds of billions. We have barely whispered, and we expect to be heard across a crowded room. It is no surprise that we hear nothing back. The signals are too weak, the distance is too great, the timescales too mismatched. We are trying to have a conversation across a chasm, and our voices do not carry. Then there is the problem of coordination. For two civilizations to communicate, both must be looking in the right direction at the right time, using the right frequency. If we are listening to a star system while they are listening elsewhere, we miss each other. If we are using radio and they are using something else, we miss each other. If they sent a signal 1,000 years ago and we only start listening now, we miss each other. The universe is vast, and the window for successful contact is narrow. It is like two people trying to meet in a huge, dark city without phones or addresses. They might both be there, both looking, but never cross paths. The silence is not evidence of absence. It is evidence of difficulty. This solution to the Fermi Paradox is less existentially threatening than the Great Filter or Dark Forest. It does not suggest we are doomed or in danger. It simply suggests we are far apart. It implies that the universe might be full of civilizations, each looking out into the night, each wondering if they are alone, each concluding from the silence that they must be. The loneliness is real, but it is not permanent. As we develop better technology, as we listen longer and more carefully, as we venture out into space, the distances will shrink. The timescales will align. Contact might be difficult, but it is not impossible. We are just very, very early in the process of reaching out. So perhaps the solution to the Fermi Paradox is simply patience. We have been listening for a cosmically insignificant amount of time. We have searched a tiny fraction of the sky. We have developed technology only recently. The universe does not move at human speeds. It moves at geological, astronomical, cosmic speeds. To expect quick answers is to misunderstand the scale of the question. The silence does not mean failure. It means we are still in the early chapters of a very long story. Other civilizations might exist, scattered across the stars, each on their own timeline, each facing their own challenges. And one day, perhaps millions of years from now, our paths might cross. Until then, we wait. We listen, and we try not to lose hope in the vastness. We have journeyed through many possible explanations for the great silence. We have considered filters and forests, distance and difference, chance and choice. But now let us turn inward. Regardless of which explanation is true, or whether the truth is some combination of all of them, what does the Fermi Paradox mean for us? How should we live in a universe that appears empty? What responsibilities, what opportunities, what emotions arise from our cosmic solitude? These are not just scientific questions. They are deeply human ones. They touch on meaning, purpose, and the shape of the future. Let us explore what it means to be, as far as we know, alone. One response to the silence is humility. We thought we would find others. We expected the universe to be full of voices. The fact that it is not, or at least appears not to be, reminds us how little we understand. It reminds us that our intuitions can be wrong, that the universe does not conform to our expectations. This humility is valuable. It keeps us curious, keeps us questioning, keeps us from arrogance. We are children in a vast cosmos, and we have barely begun to explore. The silence is a teacher, instructing us in patience and wonder. It asks us to accept uncertainty, to sit with not knowing, and to keep searching anyway. Another response is responsibility. If we are alone, or at least alone for now, then the future of intelligence in the universe depends on us. We are not just another species among many. We are the custodians of consciousness in this corner of space. Every decision we make ripples outward in time. If we destroy ourselves, we might silence the only voice calling into the void. If we survive, if we thrive, if we spread to the stars, we ensure that the universe is witnessed, that it is appreciated, that it is filled with meaning rather than emptiness. The silence is not a burden, but a calling. It asks us to be worthy of the moment, to rise to the occasion. There is also a sense of freedom in the silence. If no elder civilizations are watching, if no cosmic rules have been laid down, then we are free to chart our own course. We can define our own values, build our own future, make our own mistakes and learn from them. We are not subordinate to anyone. We are not judged by superior beings. The blank canvas of the cosmos is ours to paint. Yes, that is a heavy freedom fraught with responsibility, but it is also liberating. We are not following a script. We are writing it, and the pen is in our hands. What kind of story will we tell? What legacy will we leave for those who come after? For some, the silence brings sadness. The idea that we might be alone, that there are no cosmic companions to share the universe with, feels profoundly lonely. We are social creatures. We crave connection. The thought of an empty cosmos can be heartbreaking. And it is okay to feel that sadness. It is okay to mourn the idea of a universe full of friends we will never meet. But sadness can coexist with hope. We do not know that we are alone. We only know that we have not yet found anyone. The search continues. And even if we are alone, we have each other. 8 billion humans, all riding this fragile blue dot together. That is not nothing. That is, in fact, quite extraordinary. Others find the silence comforting. It removes certain fears. There are no alien invasions to worry about, no cosmic empires to subjugate us, no judgmental superior beings looking down on our flaws. We are safe in our isolation. We can grow at our own pace, solve our own problems, build our own destiny without external interference. The universe is a sanctuary, not a battleground. There is peace in that. A quiet, calm acceptance that we are on our own, but that being on our own is not a punishment. It is simply the state of things, and we can make of it what we will. The silence is not oppressive. It is serene. It allows us to breathe. Ultimately, our reaction to the Fermi Paradox says as much about us as it does about the universe. Do we see the silence as a mystery to solve, a threat to fear, a gift to cherish, or a challenge to overcome? The cosmos does not tell us how to feel. It simply is. We project our hopes, our fears, our values onto it, and in doing so, we reveal ourselves. The Fermi Paradox is a mirror. It shows us what we believe about existence, about meaning, about our place in the grand scheme. And maybe that is its greatest value. Not the answer it provides, but the questions. It forces us to ask ourselves, who are we? What do we want? What kind of universe do we wish to inhabit? So here we are, alone or nearly alone, in a universe so vast it defies comprehension. We do not have all the answers. You might never have them. But we have something precious. We have awareness. We have curiosity. We have each other. We have this moment right now to witness the stars and wonder at them. The Fermi Paradox is not a problem. Nina, it is an invitation to explore, to question, to dream, an invitation to take our place, however small, in the cosmic story. Whether we are the first, the last, or somewhere in between, we are here. We are conscious. We are alive. We are alive. And that, in itself, is a kind of answer. Let that be enough for now. As we near the end of our journey through the Fermi Paradox, let us turn toward hope. Yes, the universe might be empty. Yes, the challenges of finding or becoming an interstellar civilization are daunting. Yes, we face filters and uncertainties and the cold mathematics of distance and time. But hope is not unreasonable. In fact, hope might be the most rational response we can have, because we do not know the answer. And in that uncertainty, there is room for optimism, room to believe that the story is not over, that contact is possible, that the silence is not permanent. Let us explore why hope is justified even in the face of cosmic emptiness. First, consider how young we are. Human civilization is incredibly recent. Agriculture is only about 10,000 years old. Lighting is 5,000. Radio is 130. We have been seriously searching for alien signals for only about 60 years. That is nothing. Blink. We have barely started looking, and already we expect to have found something. But the universe does not work on human timescales. Discovery takes time. Patience is required. The fact that we have not found anyone yet does not mean we never will. It means we are still in the opening moments of a search that might take centuries or millennia. Hope is justified because we have barely begun. Second, our technology is advancing rapidly. Every decade brings new tools, new methods, new ways of seeing. The James Webb Space Telescope can analyze the atmospheres of distant exoplanets, searching for biosignatures. Future telescopes will be even more powerful. We are developing AI systems that can sift through vast amounts of data, finding patterns we might miss. We are launching more sensitive radio telescopes. We are beginning to explore techno-signatures, looking for evidence of advanced engineering like Dyson spheres or megastructures. We are getting better at this. The better we get, the higher the chances of finding something. The tools we will have in 100 years will make our current efforts look primitive. Third, we are learning that the ingredients for life are everywhere. Water exists throughout the solar system. Organic molecules drift in interstellar clouds. Amino acids, the building blocks of proteins, have been found in meteorites and comets. The chemistry of life is not rare. Yes, we still do not know how common life itself is, but the universe is clearly set up to make it possible. Every discovery we make increases the likelihood that life exists elsewhere. Moons like Europa and Enceladus might harbor subsurface oceans with microbial life. Mars might have once been home to simple organisms. Even finding extinct life would be monumental. It would tell us we are not a fluke. Fourth, consider the trajectory of human exploration. In the span of a single human lifetime, we have gone from the first powered flight to landing on the moon. We have sent robotic probes to every planet in the solar system and beyond. We are planning missions to Europa, to Enceladus to Titan. Private companies are developing reusable rockets. Plans for permanent lunar bases and Mars colonies are being drawn up. Yes, interstellar travel remains distant, but it is no longer unthinkable. Each generation expands the boundaries of the possible. If we can avoid destroying ourselves, if we can survive the filters and navigate the dangers, there is every reason to believe we will eventually reach the stars. And if we can do it, others might have as well. Fifth, the absence of evidence is not evidence of absence. This is worth repeating. We have searched a tiny fraction of the sky at a limited range of frequencies for a brief moment in cosmic time. Drawing definitive conclusions from such a small sample is premature. Imagine declaring that fish do not exist after checking one small pond. The ocean is vast, and we have barely wet our feet. There is so much we have not looked at, so much we have not examined. The universe might be full of life, and we simply have not found it yet. Search is far from over. The search is far from over. In fact, it is really just beginning. And that means hope is not just possible, it is reasonable. 6. Remember that discovery can happen suddenly. For decades, we had no confirmed exoplanets. Then, in 1992, the first one was detected. Now we know of thousands. The field exploded. Similarly, we might go from no evidence of alien life to definitive proof in a single moment. One unambiguous signal. One biosignature in an exoplanet's atmosphere. One discovery of microbial life on Europa. Everything could change overnight. The universe might be holding its secrets close, but secrets have a way of being revealed. All it takes is the right observation at the right time. We might be one discovery away from answering the oldest question humanity has ever asked. And that possibility should fill us with anticipation, not despair. Finally, hope is not just about finding others. It is about becoming who we need to be. The search for extraterrestrial intelligence is also a search for meaning, for connection, for understanding. It pushes us to develop better technology, to think deeply about life and consciousness, to cooperate across nations and cultures. It inspires us to look beyond our immediate concerns and consider the long-term future. Even if we never find aliens, the search makes us better. It elevates us. It reminds us that we are part of something larger. And in that sense, the journey is the destination. The hope is the point. So let us carry that hope forward, gently, like a flame that must not be extinguished. The cosmos is vast, but so is our capacity for wonder. As we approach the end of our journey, let us reflect on what the Fermi Paradox truly asks of us. It is not just a scientific puzzle. It is a philosophical challenge, an emotional experience, a call to action. Where is everybody? This question echoes through the corridors of our minds, unsettling and profound. But perhaps the question itself is the gift. Perhaps by asking it, we are already beginning to answer it. We are here asking. We are conscious, wondering. We are reaching out, hoping. In a universe that might be silent, we are the ones breaking that silence. We are the voice calling into the void. And maybe that is enough to start with. Throughout this journey, we have explored many possibilities. We might be the first intelligence to arise in a universe only recently ready for life. We might be facing a great filter that has eliminated countless others before us. We might be hiding in a dark forest where revealing ourselves is dangerous. They might be here, but so different we cannot recognize them. Or we might simply be separated by distances and times so vast that meeting is nearly impossible. Each explanation has merit. Each changes how we should think about our future. But none of them, not one, suggests we should give up. They all suggest we should proceed thoughtfully, carefully, with wisdom and foresight. The paradox is a teacher. There is something deeply human about our need to find others. We are social beings. We have always sought companionship, community, connection. When we look to the stars, we are not just looking for scientific data. We are looking for family. We are looking for someone to share this strange, beautiful experience of existence with. The loneliness we feel when we contemplate an empty universe is real and valid. It speaks to our fundamental nature. We want to know we're not alone. And yet, in our searching, in our hoping, in our reaching out, we find each other. Every person who has ever looked up at the stars and wondered, they are connected to you. You are not alone in your wondering. The Fermi Paradox also forces us to confront our own fragility. If the great filter lies ahead, if civilizations like ours tend to self-destruct, then our survival is not guaranteed. It is contingent on the choices we make, how we treat our planet, how we manage our technologies, how we resolve our conflicts. The stakes are higher than personal success or national prosperity. The stakes are cosmic. If we fail, we might silence the only voice in this region of space. If we succeed, we might become the ancients that future species look back on with reverence. The universe is watching, even if it is only through our own eyes. We are the universe becoming aware of itself. That is a responsibility worth taking seriously, and yet, alongside the weight of responsibility, there is also joy. Joy in discovery, joy in learning, joy in the simple act of looking up at the night sky and marveling at its beauty. The Fermi Paradox does not diminish the wonder of existence. If anything, it amplifies it. Each star is a question. Each planet is a possibility. Each new discovery is a step toward understanding. The search for life beyond Earth is not a grim duty. It is an adventure. It is humanity at its best, curious and courageous, reaching beyond the familiar into the unknown. Whatever the outcome, the search itself is meaningful. The journey itself is worthwhile. And we are privileged to be alive during this extraordinary time of exploration. As you return to your daily life after this journey, I invite you to carry the Fermi Paradox with you, not as a burden, but as a companion. When you face challenges, remember that you are part of a species trying to navigate the cosmos. When you feel small, remember that you are made of stardust, forged in the hearts of ancient suns. When you feel alone, remember that billions of humans share this planet with you, all of us riding through space together on our fragile blue home. And when you look up at the night sky, let the silence speak to you. Let it remind you that mysteries remain, that wonder is still possible, that the universe is vast and strange and beautiful beyond imagining. The question of where everybody is remains unanswered. And perhaps that is okay. Perhaps some questions are meant to live with us, to shape us, to guide us forward without resolution. The Fermi Paradox is not a problem demanding a solution, but a mystery inviting contemplation. It asks us to think deeply about life, intelligence, meaning, and our place in the grand scheme. It asks us to be humble and hopeful simultaneously. It asks us to take care of our world while reaching for the stars. It asks us to be both realistic and idealistic. These are no contradictions. They are the balance we must maintain. The question is the path, and we walk it together. So here we are at the end of our exploration of the Fermi Paradox, but also at a beginning. a beginning of new questions, new observations, new possibilities. The universe remains vast and largely unexplored. The search continues. And you, right now, listening to these words, you are part of it. You are part of humanity's attempt to understand itself and its place in the cosmos. That is no small thing. Whatever the answer to the paradox may be, whatever revelations await us in the decades and centuries to come, we are here now, conscious and wondering. And that itself is a kind of miracle. Thank you for joining me on this journey through the cosmic silence. May you find peace in the questions and courage in the unknown. Our contemplation of the Fermi Paradox comes to a close, but the question lives on. In the silence of the cosmos, we have found something unexpected. Not answers, but reflections. Not certainty, but wonder. The universe has asked us where everybody is, and in searching for the answer, we have discovered more about ourselves. We are curious. We are hopeful. We are resilient. And whether we are alone or simply early, whether we are the first or the last, we are here. That matters. The next time you look up at the stars, know that you are connected to every person who has ever asked these questions. We are all fellow travelers on this cosmic journey. What will you do with the knowledge that we might be the universe's only witnesses? How will you live knowing that consciousness itself is precious and rare? These questions are yours to answer now. Rest well, dream deeply, and may the stars guide you toward wisdom and peace.